Welcome to the Journey Chez Chem. Well, today you have another redox reaction to balance in basic solution. And then we're going to have a lab. I'm so excited. And we'll just do it together, and then you'll do part of it at home. So please do the warm-up question as quickly as possible, and we'll discuss it in a moment. Now, as always, we have to get the oxidation numbers of all of the elements. Now, here, chlorine is a diatomic molecule and its oxidation number is 0. Here, we have a polyatomic ion with an overall charge of -1. Oxygen is -2 as it is on its periodic position. And therefore, in this case, chlorine is +1. And here, obviously, it is an ion and it has a -1 charge. Therefore, we have changed. And you see that we have one thing that goes to 2. And sometimes we could have only one on the product side. It's doing both things. Now, chlorine is going from 0 to +1. It lost 1 electron. It is oxidized. It also gained 1 electron here and is reduced. Therefore, when I separate them, I'm going to separate the chlorine and handle each one individually as a half reaction. And I have 2 chlorines here, therefore I need a coefficient of 2 to get those 2 chlorine atoms. Now, I have lost 1 electron for 1 atom, but there are 2 atoms, so I lost a total of 2 electrons. Now I need 2 oxygens, and therefore I'll add 2 waters. Well, in basic solution, when I add those 4 hydrogens, I'm also going to add 4 hydroxide ions as well. And together, those make 4 waters. And 2 of those waters cancel with these 2, leaving me 2 on the product side. Then that one is balanced. The next one, I again take the chlorine diatomic molecule and make the chloride ion. I need 2 of them because there are 2 atoms. Now I have gained not just 1, but 2 electrons because there are 2 atoms of chlorine. And I don't have to multiply by a common multiple. That makes it very, very straightforward. And there's nothing else I have to do with the chlorine here. There's no oxygen. I don't need any hydroxides. Therefore, I'm just going to add them together, and my electrons completely cancel, and I add these 2 chlorines. So I get 2 chlorines. And I believe I forgot something. I have to have 4 hydroxides on this side as well. Remember, we must add the hydroxide to both sides of the equation. Now, so I have my 4 hydroxides here. I get 2 chloride ions, 2 hypochlorite ions. They're both -1, and 2 waters. Now you can see that we can lower the ratio here, and I can divide everything by 2, so I get 2 hydroxides, chlorine, chloride ions, hypochlorite ions, and water. And that is my final answer. And chlorine is everything. It's the element oxidized and reduced. It's the oxidizing agent and the reducing agent. And it does everything. And the total number of electrons that are transferred in both cases are 2. And for the complete reaction, it's 2 electrons. And that was very straightforward. And I will see you in a moment, and we will discuss the labs. I get so excited doing lab. Well, this is a really fun little thing. I'm going to show you a demonstration and you are going to write up a complete lab report. It's really very, very basic and very straightforward. So you should do very well on this, as I know that you do on most things. So this is a demonstration and you have a lab sheet that tells you the various parts that need to be on here. And there are some conclusion questions that we need to discuss so that you can do them on the lab. And then you come up with your own 2 further investigation questions and answers. You can find those in your warm-ups if you're having a struggle finding something like that. Well, the first thing I'm going to do is take a 250 milliliter beaker. And then I am going to add approximately 0.50 grams. And I say approximately because this is really very qualitative. You can see that the crystal is blue. And I'm going to put some of this crystal into this beaker, and then I'm going to dissolve it in some water. Dissolve it in water. And you can see that it is a blue, clear blue water. The copper ions have a blue color that looks like this, and it's very characteristic, very, very well known. Now, I am also going to take about 1/4 gram, 0.25 grams of steel wool. And steel wool is made of iron. It is just elemental iron. And I am going to put this steel wool into this solution. And I'm going to allow it to sit for approximately a minute. And I will show you what it's going to end up looking like. It's going to end up looking like this. So the solution is going to go from this nice, beautiful blue to this greenish, yellowish solution. And while we're waiting for this to react, let's look at the reaction on the board. We have copper 2 sulfate, and in this sulfate has a -2 charge, and therefore copper is +2 here. And iron is 0, it's elemental, it's standing by itself, therefore it's 0. Now when we see this, we see it is a single replacement or a single displacement type of reaction, where the iron is going to displace and take the place of the copper, and therefore we are going to have the iron to sulfate and the copper. Now, when I look at this, I see that the sulfate has stayed in its form, and therefore the sulfate is what we call a spectator ion. It has not changed in the reaction. And therefore, here, sulfate is -2 and iron is +2. And copper is standing by itself, and therefore it's 0. And from these charge changes, you can figure out what has been oxidized and what is being reduced. And I believe that I've told you all the things that you need to know about that. And before we take a look at the reaction and how it's going on, I want to tell you a little bit about the lab that you're going to do at home. You are going to take an iron nail. Now, it's very important to have an iron nail because if it's not iron, the reaction won't happen as well. Therefore, be careful of those galvanized nails. If you see the nails a little rusty, that's probably a pretty good indication that it's iron. And you're going to need a soap pad to scrub it up a little bit and some pennies. And the rest of it should be very straightforward. Now, when you write up this lab of the demonstration, you can look at the data table that's given to you where you're just looking at the colors. What was the color before and what is the color after? And what we had in this demonstration is we had the colors of the solutions, and we also had the color of the steel wool. And let's take a look at this. The steel wool here was originally gray, and you can see now that it is reddish color. It's copper colored because it is copper. The iron solid is going into solution, and the copper that's in solution is going onto the iron. They are being displaced. Pretty cool, huh? I like it. It's nice and simple, and we can even see that on the bottom of the beaker, the copper is being dropped off. As it becomes heavy, it drops away from the rest of the iron. And that is a redox reaction. And you'll have fun with the one that you're doing at home. It's pretty exciting too. So there you have it. That's 2 labs that you can do, and both of them are due on the first day of the second week of the 4th quarter. Wow, we're just moving right along. Well, thanks for being here. I love having fun with you, and I can't wait to see you tomorrow. Bye.